My name is Muhammad Nabi Asfar bin Muhammad Najib and my student ID is 20234544914.
So, Assalamualaikum. My name is Muhammad Rafiq Syamil bin Muhammad Zamani and my student ID is 202349886.
Hi, Assalamualaikum. My name is Muhammad Hakim bin Muhammad Fazil. My student ID is 2023620656.
Hi, Assalamualaikum. My name is Nadia Adin Sofia binti Sharul Nazri and my student ID is 20238443888.
Assalamualaikum and hello everyone. My name is Farhana Batusha binti Majastri and my student ID is 2023614482.
For this section, I will introduce two types of retaining wall systems, which are the Nehemiah wall and the Teramish wall. First is Nehemiah wall. It is a modern pattern reinforced soil retaining wall system. It is designed to reinforce soil so that slopes and vertical cuts remain stable and safe. It is known for its interlocking hexagonal precast concrete panels. The interlocking shape improves wall strength and prevents movement between panels. This system is reinforced by galvanized steel bar. These bars increase tensile strength and are protected against corrosion, ensuring long-term durability. Moreover, it is anchored by precast concrete block. This block helps transfer the soil load deeper into the ground. This block acts like a single solid mesh that can resist soil pressure. This allows the wall to effectively resist pressure from the soil behind it. Next is Teramish wall. It is a type of mechanically stabilized earth. It stabilizes soil by reinforcing it with structural elements. The structure uses a pre-assembled polymer-coated double twist wire mesh. This coating protects the mesh from corrosion and improves durability. This system uses a continuous mesh panel with internal diaphragm. The diaphragm helps maintain the wall shape and support the soil, allowing it to adapt to ground movement without cracking or failure.
Going to explain about the advantages of Nehemiah and Teramish wall. Both of them are similar advantages but in different perspectives. So for Nehemiah wall, cost efficiency. The Nehemiah wall is cost efficient because it uses less concrete and steel. Its stability mainly comes from the reinforced soil, which help reduce material, labor and overall construction costs, especially for long retaining walls. Faster construction. Construction is faster since the wall uses precast panel and a simple installation method. This allows site works to progress quickly and help minimize delay in the project. Flexibility and stability. The Nehemiah wall is designed to be flexible so it can accommodate minor ground movement without cracking or damage. This makes it suitable for soft or uneven ground condition. Aesthetic and environmental benefits. In terms of appearance, the wall offers various panel finishes and allow landscaping to be added. This helps the structure blend better with its surrounding and makes it less visually intrusive than traditional concrete walls. Long-term performance. The Nehemiah wall provides good long-term performance. It is durable, resistant to corrosion, and requires minimal maintenance, resulting in reliable performance and lower long-term costs. Move on to Teramish wall. High flexibility. The Teramish wall is highly flexible because it uses steel wire mesh together with reinforced soil. This allows the wall to accommodate ground movement and settlement, making it suitable for soft or uneven ground while reducing the risk of cracking or failure. Cost effectiveness. The Teramish wall is cost effective as it uses locally available backfill and requires less concrete than conventional retaining walls. Its lightweight, mesh and simple construction method help reduce material, labor and transportation costs. Simple and fast installation. Installation of the Teramish wall is simple and fast because it uses modular wire mesh unit that can be easily assembled on site. Only standard equipment is needed and minimal foundation work allows construction to progress quickly, especially for projects with tight schedules. Environmental and aesthetic benefits. The open mesh facing allows the vegetation to grow through the wall, giving it a natural appearance over time. This makes the Teramish wall suitable for environmentally sensitive area and help reduce visual impact. Long-term performance and durability. The Teramish wall provides reliable long-term performance. With galvanized or coated wire mesh and effective drainage, it resists corrosion and water pressure, requires low maintenance and ensure long-lasting durability.
So now I'm gonna explain about the disadvantages of Nehemiah walls in Malaysia. So the first point is sensitivity to weak subsoil. So the most common issue in Malaysia is common soft clays and weathered soils, which often require extensive ground treatment. Next, we have hydrological and climatic risk. which are high tropical rainfall and monsoon event, risk water increase, and high pore water pressure, which demands complex drainage system with whole subsoil drain and strict supervision to prevent lateral pressure build-up or backfill erosion. The third point is logistical and terrain constraint. The issue is steep hillside and narrow access road restrict the delivery of heavy precast panels and machinery. So it impacts into reduced productivity in remote or confined area, necessitating expensive temporary works or staging. The last point is design and supervision rigor, which success is highly dependent on precise geotechnical investigation and high quality installation. So next, I'm going to go to disadvantages about Terra Mesh Wall in Malaysia. The first one is excavation and subsurface obstacle. The issue is mixed soil profiles containing boulders or shallow bedrock, common in Malaysia. Hillsides hinder foundation preparation. This gives an impact about require mechanical braking, leading to slow progress, frequent design revision, and unexpected cost overruns. The next one is backfill material sourcing. The issue, Terra Mesh system require specific high quality granular fill to ensure friction with the geogrids and mesh. It impacts into high cost and logistical delay when the projects are far from proof quarries, using marginal local soils, and can lead to wall bulging or excessive settlement. The third point is compaction and moisture sensitivity, which is the issue. Our performance relies heavily on achieving precise soil density. It impacts Malaysia high humidity and rainfall, make it difficult to maintain the optimum moisture content during construction, risking long-term constructional deformation. The last point is drainage and hydrostatic pressure. The issue is despite the permeable look of the mesh face, internal water accumulation is a major risk during monsoon. Thank you.
So next, I'm going to explain about the method of construction for both Nehemiah Wall and Terra Mesh Wall. For Nehemiah Wall, it consists of 7 main steps. Step 1. Site preparation. The construction site is clear from all vegetation and set out accurately as defined in drawing. For step 2. Excavation work. The excavation is carried out to achieve stable formation level for wall foundation. Step 3. Foundation preparation. The excavated formation is trimmed to prepare for foundation. Step 4. Lean concrete. Lean concrete is laid to provide level and stable base to construct foundation. Step 5. Wall construction. Nehemiah Wall is constructed by using reinforced concrete or precast concrete in stages based on drawing. Step 6. Backfilling. Backfill material is placed behind the wall in compacted layers to ensure stability of the wall. And step 7. Capping and finishing work. A capping is constructed on the top of the wall, followed by finishing work. The next one is Terra Mesh Wall. For the method of construction for this wall consists of 8 main steps. Step 1. Site preparation. The site is clear and the wall level are accurately set out to ensure correct position. Step 2. Excavation work. Excavation is carried out to accommodate the foundation and embedment of Terra Mesh Wall. Step 3. Foundation preparation. The foundation level is compacted, followed by placement of granular foundation layer. Step 4. Placement of Terra Mesh unit. The first row of Terra Mesh unit is positioned carefully and aligned on foundation. Step 5. Backfilling. Selected granular fill material is placed within the wall and carefully compacted to avoid deformation. Step 6. Success layer installation. Subsequent wall layers are installed progressively until the design wall height is achieved. Step 7. Drainage work. Drainage layer, filler fabric, and drainage pipes are installed behind the wall to ensure efficiently water removal. And step 8. Finishing work. The top of the wall is finished with coping, followed by final inspection to confirm the specification requirement. Thank you. I will pass this to next for my friend.
I will explain some of the common problems encountered during the construction of a Nehemiah wall and the solution used to overcome them. One of the main problems is the use of poor or unsuitable backfill material. Since the stability of the Nehemiah wall depends on the interaction between the soil and the reinforcement, using materials such as clay, organic soil, or polycompacted fill can cause settlement and wall movement over time. To solve this problem, well-graded granular backfill should be used. The soil must be compacted in thin layer, and regular inspection and testing should be carried out to ensure proper compaction and long stability. Another common issue is the misalignment of precast concrete facing panel. This usually happens when panels are not properly leveled or supported during installation. Misalignment can affect both the structural performance and the appearances of the wall. This problem can be prevented by using accurate leveling tool, alignment guides, and string lines. Temporary bracing should also be provided, along with the close site supervision, especially during the early stage of construction. Next is the drainage issue are also concerned, particularly in areas with heavy rainfall or high groundwater level. Poor drainage can cause water to accumulate behind the wall, increasing pressure and reducing stability. To address this, proper drainage systems such as granular drainage layers, perforated pipes, and weep holes must be installed to allow water to flow out safely.
Problem commonly encountered in Terra mesh wall construction and their solution. One major issue is the corrosion of the steel wire mesh, especially in aggressive environments such as coastal area or location with high humidity. Over time, corrosion can weaken the mesh and affect the durability of the wall. To reduce this risk, galvanized or polymer-coated steel mesh should be used. The design must also comply with durability requirements suitable for the site condition, and regular inspection should be carried out. Another challenge is the failure of vegetation to grow on the wall face. Since the mesh walls are designed to support natural vegetation, poor plant growth can affect both appearance and erosion control. This problem can be solved by using suitable topsoil within the mesh, selecting plant species that match the local climate, and providing adequate watering and maintenance during the early growth stages. Construction quality control is an important concern. Poor workmanship, such as incorrect mesh connection, improper reinforcement placement, or uneven compaction, can reduce the wall stability. To overcome this, clear construction guidelines should be followed, and regular supervision and inspection must be carried out to ensure proper installation and compaction.
Today, I will be explaining several new technologies used in the construction industry, which are Building Information Modeling, or known as BIM, prefabrication and modular construction, advanced construction machinery, and the use of drone. First, I will explain Building Information Modeling, also known as BIM. BIM is a digital technology that allows construction projects to be planned, designed, and visualized before actual construction begins. Instead of relying on a traditional 2D drawings, BIM uses a 3D digital model that contains detailed information such as dimensions, materials, quantities, and construction sequences. Through BIM, professionals such as architects, engineers, quantity surveyors, and contractors can work together using shared model. As a result, errors are reduced and cost estimation becomes more accurate. Next, prefabrication and modular construction. Prefabrication involves manufacturing building components off-site in a controlled factory environment before transporting them to the construction site for installation. Modular construction is similar, but it involves assembling complete units or modules such as rooms or sections of a building. These methods allow construction to be completed faster because on-site work and off-site work production can happen at the same time. Moving on to advanced construction machinery. Advanced construction machinery includes equipment that use modern technologies such as GPS guidance, sensors, and laser leveling system. These machines help operators carry out tasks like excavation, grading, and leveling with high accuracy. With the use of GPS and laser system, construction work can be done according to precise design specifications, reducing human error and rework. This increased productivity, improves construction quality, and reduces material waste. Advanced machinery also helps speed up project completion while maintaining accuracy. Finally, I will explain the use of drones in construction. Drones are unmanned aerial vehicles that are commonly used for site inspection, surveying, and progress monitoring. They can capture aerial images and videos quickly and safely, even in difficult or hazardous areas. Drones allow project teams to monitor construction progress in real time and make better decisions based on accurate data. They also improve safety by reducing the need for workers to access dangerous locations. Overall, drones enhance efficiency, safety, and project management in modern construction projects. In conclusion, the adoption of new technologies such as BIM, prefabrication, and modular construction advanced machineries, and drones has significantly improved efficiency, accuracy, and sustainability in the construction industry. These technologies help the industry meet modern demands and overcome future challenges.